Okay, welcome to my YouTube channel, viewers. I am Precious Ugweze, and in today's video, it's going to be a continuation of our lesson on set theory. You remember that we have defined set theory and we have also discussed about set operations, that is, how you can combine the relationship between two sets and you'll be able to get another set. And so we're able to see the union of sets. We saw the intersection of sets and what it's all about. We saw also the difference of sets and so on and so forth. And so now today we're going to continue with Venn diagrams. And so what is Venn diagram? So we notice that Venn diagram is just a way of representing this relationship between two sets diagrammatically. So when you're able to represent the relationship between two sets in a diagram, you call that diagram a Venn diagram. It was introduced by a man called John Venn, and so it was named after him. Okay, so now the first one here talks about the union of two sets. So you can see here, you have set A and set B. And so you can see that, please note that in Venn diagrams, we use the block, that's a rectangle. We use a rectangle to represent the universal set, and we use circles to represent the different subsets of that universal set. So like here you can see we have set A and set B inside a rectangle which is represented as a universal set. So all of these are universal sets, including this. You remember there are two signs that you can use to represent the universal set. So all of these are universal sets. Okay, so while the circles inside represent the small or subset of that universal set. Okay, so now you can see for the union of two sets, now it's by definition, it is a set that contains all the elements of the two sets without repetition. And of course, you can see, or you can say it is the set that contains the elements that are either in A or in B or in both of them. Like here, you can see this place. The center here talks about the elements that are in A and also in B, but you just pick them once. You don't repeat any of them. Okay, so this shows you the shading of the two circles, including their overlap, gives you the union of the two sets. And then also this is for the intersection. You can see the shaded portion, that is the set of elements that are in A and also in B. So that gives us the intersection of the two sets. And then we have the subset. So you can see set A here now is completely contained inside set B, just as I defined that subsets are sets that are all the elements are contained in another set. So you can say here now that A is a subset of B, and this is the Venn diagram representation. And now the fourth one we have here is complement of set. Remember we said that there are those elements that are in the universal set. You can see the shaded portion tells you that these elements are inside the rectangle but not found inside the circle. The circle is set A, but the rectangle is the universal set. So there are the elements in the rectangle, the universal set, but not contained in the complement of the set. Okay, and then we go to the fifth one, talking about difference of sets. Remember, under set operations, we talked about difference of sets. So here we have that A difference B, that is the shaded portion here, set of elements in A, but not in B. Elements in A, but not in B. And then another representation for that is A intersection B complement. Of course, you can see that aside this circle now, everything outside this circle is A complement. Outside this B circle, that's this second circle here, is B complement. And then whereas here is your A. And so you can see that this shaded portion is inside A and also inside the complement of B. So that means they are the elements contained in A and also in the complement of B. That's why we can as well call it the intersection of A and B complement. That is A difference B. And then you can see this one is B difference A. That means elements in B that are not found in A. And you can as well call it B intersection A complement or A complement intersection B. Okay, so now these are the basic Venn diagrams that we have, that we can use to represent the relationship between two or more sets in some cases. Now we have practical examples because we make use of this Venn diagram too. It is very useful in solving problems, especially set problems when they are in words, when you have word problems like this. And so this is an example. Now let's look at this problem before we go into what we call the algebraic properties of set operations, which we are going to discuss just after maybe this problem and maybe another one. Okay, so now let's see. It says a survey showed that of 100 final year students of a school, 63 entered for geography. So we are going to begin. Now, the first thing you must do when you are given a word problem of under set is, first of all, you bring out the data you are given, and then so you'll be able to represent it, in a Venn diagram. Okay, so let's go. It says that 63 entered for geography. That means the n of G, let's use G to represent geography, is 63. And the next one, 47 entered for biology. N of B for biology is 47. And then what again? 40 entered for N of, it says 40 entered for chemistry. Let's use C for chemistry. 40 entered for chemistry. Okay, and then now it says 25 of these students entered for geography and biology. That is to say that N of geography, do you remember geography and biology means geography intersection biology. That means the number of students that entered for both geography and biology is given as 25. And then what again? It says 18 for geography and chemistry. That means, remember, this N means cardinality. That means the number of students that entered for geography intersection. That means people that entered for both of them, for geography and chemistry, G and C, is 18. Am I correct? Yes, 18. And then again, what do you have? It says, while 22 entered for biology and chemistry. 22, N of biology and chemistry is 22. Okay, and then they said, now that if 10 students entered for the 3 subjects, what does that mean? The number that entered for the 3 subjects signifies the number that will be found in G intersection B intersection C. That means there are people that are doing the 3 of them. So that means the N of G intersection B intersection C is equal to 10. And then they say use a Venn diagram to find all of this. Now, even without telling you to use a Venn diagram, we should know that a Venn diagram will be very useful for us in solving this problem. So what are we going to do? Now, very simple. Let's represent this information in our Venn diagram. Remember that the rectangle stands for the universal set. So the universal set for this problem is going to contain all the 3 sets. So we have the first circle is for G. Now the second circle is for B. And the third circle is for our C. Now the 3 circles are overlapping because there are some students who are offering the intersection of the 3 of them. And so there's going to be an overlap for the 3 of them. And so what are we going to have now? When you are interpreting or representing a problem on Venn diagram, please note, always start from the intersection. If you have 2 sets in a problem that you are representing on Venn diagram, you always start representing from the intersection. If there are 3, always start from the intersection of the 3 of them. If there are 4 sets, no matter the number, always start from the intersection, the biggest intersection. That means if there are 3, start with the intersection of the 3 before you go to the intersection of the individual 2's, and so on and so forth. So this one, we're going to begin with the intersection of the 3, and here we have 10 students. So the cardinality here is 10, and then we go to the next intersection. B and G is the first intersection after this. B and G is 25. Now, the reason why you are supposed to start from this intersection, the one that is the biggest intersection, is that for you to represent what you're supposed to have here now, you are going to see that if you write 25 here, the answer that is going to be incorrect. The reason is because the intersection of, look at this, intersection of G and B is the whole of this space. The whole of this. However, there is a removal of 10 from it to enter for the intersection of the whole tree, assuming you add the next set. So that is to say that out of the 25 that you were supposed to have here, out of the 25 that was supposed to be here, now 10 has been removed. And so the remaining you should have here shouldn't be 25. Rather, that you are supposed to have 25 minus what? 10, which is what? 15. So that's why it's always very important to start with the innermost, or what I call the biggest intersection. That is the intersection of the whole set considered under that universal set. Okay, so here we have 10. That means the remaining here should be what? 15. How about here? G and C is 18, but you have removed 10 from it. That means you are going to have 8 here. Now, while B and C is 22, but you have removed 10, that means I should have 12 here left. Okay? And then the next thing we have now is, okay, what do we now have left for all of this? What do we have left at this position? Okay, now this place, by my definition from that Venn diagram, is a set of elements of students that are, going for only geography. And this is a set of students going for only biology. And this is a set of students going for only what? Chemistry. You see that by representation of your Venn diagram, you've actually answered the whole question that is being asked here. You really did not need to bother yourself. The Venn diagram has actually helped you to handle that. And how do you get that? Now, remember that the circle here, the first circle you have here for G, represents the total number of students that went for geography. And by our question, 63 students went for geography. Now, but by the Venn diagram, you have first of all removed 15 here, and you have removed 10 here, and you have also removed 8 here out of my 63. And so the remaining, after you have removed all these 3 numbers, is what you are going to find in this place. And so that means that the G only is going to be 63 minus 15 minus 10 minus 8. And when you do that, you are going to get 53 minus 15 is going to give us 48. Minus 10 is 38, minus 8 is 30. So you have 30 here. And the same thing is applicable for the remaining other parts of this Venn diagram. Okay, here, that means here you are going to have, what do you have there? 47. So you are going to have 47 minus 15, which is 32. 32 minus 10, which is 22. 22 minus 12. That's going to give you 10. So you would see that if you add up everything that is in the circle of this B, you would definitely get 47, which is the total number of B students. And then while here you are going to have, you have 40 here. 40 minus 10 is 30. 30 minus 8 is 22. 22 minus 12 will also give you 10. And you will see if you add up everything here also, you will get 40. And so this is our Venn diagram. However, notice that when we go down now to answer the questions we have, let's begin with the first one. The first one says the number of students for geography only. For number of students for geography only, the answer is number of students for geography only is simply equal to 30. And then for the second part, you have number of students for biology only. Number of students for biology only is simply 10. And then the third question there says that we should find the number of students who did not enter for any of the 3 subjects. Okay, now note that the number of students, this is our universal set. which is 100 according to the cardinality of the universal set is 100. That's what the question says, that the survey showed that 100 final year students. So that means the cardinality of this is 100. And so now for you to say that the cardinality of this is 100, that means the total number of students in the whole of this rectangle must be equal to 100. And if that is true, that means if I add up everything here, I should get 100. Now, however, before then, what is the number of students who did not enter for any of the three subjects? That's the complement of these three. That means people outside these three circles. And so let us call them X. They are outside. By my Venn diagram, there are people that you will find outside if you shade this outside, apart from people inside these three circles. And so what do you do there? So that means for me to find the value of this X, all I need to do is add up everything in this rectangle now. It must be equal to 100. And so when I do that, I'll make X the subject of the formula, and that will give me the value of X. So let's do that. So if I add up everything in this circle, of course, we are going to get 63. So you are going to have 63 there, plus this 10, plus this 12, plus this 10, and then plus the complement, which is what? X. And everything must be equal to the cardinality of the universal set, which is 100. And that's going to give us 73 plus 12 is 85. 85 plus 10 is 95 plus X equal to 100. Therefore, our X is equal to 100. Take over this, that will be minus 95. Therefore, our X is finally equal to 5. That means there are 5 students who did not offer either of chemistry, biology, or geography. Okay, the next problem. Let's look at the next problem. So now we have a second problem here, which we are going to look at briefly. Now, this is also a very beautiful one. It says, in a group of 20 teachers in a school, 10 teach mathematics, 9 of the teachers teach physics, and 7 teach chemistry. So to begin with, I said we should always bring out the data we have. So we start with the total number of teachers, which is the universal set. So the cardinality of the universal set is 20. And then there are 10 of the teachers that teach mathematics. And so let's use M for mathematics. The cardinality is 10. And there are 9 of the teachers that were handling physics, 9. And now we have the cardinality of the third one, which is chemistry, is 7. Number of teachers teaching chemistry is 7. Now, the other information says that 4 is teaching maths and physics. So the number of teachers, remember maths and physics again now is M intersection P. So they said 4, and then we have none is teaching maths and chemistry. Okay, that means the intersection of maths and chemistry is an empty set. And so, what does that really tell us? It's telling us that if nobody is teaching maths and chemistry, it then means that nobody is going to take the 3 subjects. That means the intersection of the 3 subjects is going to be empty. And that's going to help us in representing this information on our Venn diagram. And now, these are the only information we are giving. So the question we now have is that we should find the number of people teaching only physics and chemistry, and the number of people teaching only physics. Okay, so now how do we handle that? So let's have our Venn. And so why are we doing that? We are doing that because there is no connection for the 3 of them. There's no intersection for the 3 of them. So now watch, you have to be very careful here. The ones that are going to be at the extreme, the 2 subjects that are going to be at the extreme are those ones that did not connect, and that is maths and chemistry. So my math can be here, and my chemistry will be here. So that means physics will be at the center because physics connected with maths here. 4 is teaching maths and physics, and physics is connecting with chemistry in the question we are given. And so that means this is the connection for the two of them. And so please note, like I said, that in representing on Venn diagram, always start with the intersection. So that means I will start with this. So here now, physics and maths is 4. So there are 4 teachers here. And then what again? In the question, they are asking for physics and chemistry. We don't know it. So let's give it a name. For physics and chemistry, let us call it X again. So we don't know X, and so on. We are looking for that. And so now what are we going to have here and here? Remember that this is your universal set. This is our universal set, and its cardinality is 20. Okay, so what are we going to have here? Now, what are we going to have here is the set of teachers that are teaching maths only. And so if I remove the intersection with physics, I will get what is here. Maths is 10, so if I remove 4, I will have 6 here. Now, what am I going to have here? The number of teachers teaching only chemistry, and that is 7 minus this intersection. So we are going to have here 7 minus x. Since I don't know x, I will just represent it as 7 minus x. In the last question, we knew the value of all the intersections, but here we don't know the value of P intersection C. So we'll call it X, and so that means the remaining here will be the total in that circle, which is 7, minus this intersection, which is X, and that will give us 7 minus X. And so what is now going to be here? That means the number of teachers that are teaching only physics. The ones that are not teaching physics, maths, and chemistry and all of that, they are teaching only physics. Okay, and what are we going to have there? Remember, the number of teachers handling physics is 9. So if I remove the intersection of physics with maths, which is 4, so I'm going to have 9 minus 4. Then minus the intersection between physics and chemistry, which is x. And so that's going to give me 9 minus 4 is 5. So I'm going to have 5 minus x as the value that will be left here. 5 minus x. And we are done. And you can as well represent this information in another form if you want. But this is okay, and we can go with this. So we can then go to our question. Now, please note another vital information. They didn't tell us that there is any complement. That means the number of teachers involved are all involved in either this maths or physics or chemistry. So no value outside the 3 of these circles. So that means if you take the union of these 3 sets we have here, you are going to get 20. Okay, and that is going to help us to find the value of x, which we are going to look for now. And that's the first question we have. So for x, what do we do? Add up everything here. Take the union. If you take the union, it must be equal to 20. And that's going to give us 6 plus 4 plus 5 minus x plus x plus 7 minus x, and everything is equal to 20. So here this x will take away this x. 6 plus 4 is 10, 15, and that is going to give us 22. So we have 22 minus x is equal to 20. And if I take my x to this side and take 20 to this side, I'll have this is equal to x. Therefore, my x is equal to what? 2. So there are 2 teachers that were teaching physics and chemistry. And that is the answer, which is what? X. Sorry, which is equal to x as what? 2. And so finally, to now do the second part of the question, which says the number of teachers taking only physics. And remember I said that this is the portion. If you shared this place, that will give you the portion of teachers teaching only physics. And so only physics is equal to our 5 minus x, which is this. And since our x is 2, so you remove 2 from 5, and that will give you the required answer. And so that is a solution to the second. Next is to look at some basic algebraic properties of set operations. There are basic algebraic properties of set operations. Let's see them. Some of the algebraic properties of set operations. Okay, so and we have a list here. not exhaustive anywhere. There's another one we're going to talk about. These properties are very important because there are problems you will encounter in set theory that if you don't have knowledge of these properties, it will be difficult to handle such problems or solving such questions. And above that, it is all of these are coming from definitions. Meanwhile, remember that most important aspect of mathematics is actually definitions. Okay, so we start. It says the commutative property. This is a property that says that if I take the binary operation of two things, that in a particular pattern, if I turn it the other way, it should remain the same. So this is saying that intersection of sets is commutative. I mentioned it in one of my videos. Intersection of sets is commutative. That means if I say A intersection B, it should give me the same as B intersection A. Just as we know that the normal addition of numbers is commutative. That means if we say 3 plus 2 is the same as 2 plus 3. So that's the meaning of commutativity. If you have any two sets, if you take their union, A union B, no matter the pattern, B union A will still be the same. But the third one is telling us that it doesn't hold for difference of two sets. That means A difference B is not the same as B difference A. If you check the other lesson, you will see where we saw that, of course, that from the Venn diagram, that where you have your A union B is not the same as where you have your A minus B is not the same as where you have your B minus A. Okay, now, and so these are the three basic commutative properties. Now, what about associativity? Associativity is saying if I have three sets and I want to take the intersection of the three of them, that of course, you know, this is a binary operation. You can only take two at a time. So I can only take the intersection of two, then I will then take my answer with the third one. So associativity is saying if I choose the last two, if I take the intersection of the last two before then taking the answer of that with the intersection of the first, that it is the same as taking the first two with the last. And that also holds for associativity. And we saw that when we're talking about, if you check my video on types of numbers, you will see that when you have, for example, Z, which is set of integers, say intersection N, which is a set of natural numbers, maybe intersection R, which is set of real numbers, that this is going to give you the same as, okay, now what we are saying here is that if I take associativity, if I decide to take these first two, that I'm going to get the same as when I decide to take these two first, then before taking it with Z. Okay, and you can check that. Remember that if you watch that video, you'll see I said, please try to check it. That intersection, which we are going to see here in any case, that if a set is smaller than the other, if you take their intersection, you should get the smaller set if it's contained in the other one. And since N is contained in Z, that means this intersection should give me N. And so if I take it with R, I should also get N as my final answer. And if you do that here, if you take with N first, with R first, you're also going to get N, since N is smaller than R and is contained in R. And if you eventually take it finally with Z, you will still get N. And that gives you the same thing. So associativity is a property in set operations for intersection. And it also holds for union. That is if you have all of the three. The two operations as union, union, or intersection, intersection. If one of it changes to maybe this is union and this intersection and the other one is union, associativity does not hold in that case. Okay, the third property we have here is what we call the idempotent property. That is where you have a binary operation act on two things and give you the same thing. On the same element, it acts on the two, it picks the element twice and the binary operation acts on it and then gives you the same element. We call it idempotence. Okay, so when you have intersection of A with A itself, it will always be idempotent. You will still get A. And when you have the union of a set with itself, you still get A. And that's the idempotence. Then we have set absorption, which is the property I was talking about here. And this is the general case. Now, when you have A union A intersection B, you are going to get A. Why? Because A is actually a superset of this. Please, maybe you can note that here, that A intersection B is actually a subset of A. And A on its own is actually a subset of A union B. In fact, this is a subset of this A intersection B is also a subset of B. Please take note of this property, it's very important. And you can see that from the general case here. I said here in general, if any set is contained in another, then their intersection is going to give you the smaller set. So since A is contained in B here, A intersection B will simply give us A. And since then the union would simply give you the bigger set. That's exactly what I used here. So N is inside R, the intersection will be N. And if I take the union, I'll definitely get the what? The R. Okay, so that's the property we used here in set absorption. And so A is actually containing the intersection. And so you will have that this union is going to be A because A is bigger than this. And the intersection of, now look at the other property you should also note. What is it? That if I have union of two sets, A union B, then each of them will form a subset because the union is containing all the two sets, elements in the two sets. That means A should be a subset of this and B should also be a subset of this. Please take note of these four properties I just wrote here. And so what that means is that since A is contained in the union of A and B, therefore if you take the intersection, you will get A because A will be the smaller one. And even if you put B here, you will still get B. If you put B here, you will also get B. And that is what we call the absorption property of set operations. Now we go to set identity property. So this one is the one that it takes your operation, it gives you one of the elements or one of the sets, sorry. So, and what are they? If you take the intersection of a set and the universal set containing that set, you definitely get the small set because it will always be inside and it obeys this rule here. Because A will always be inside the universal set, so it will be a subset. And so when you take the union, when you take intersection, you always get the smaller one, which is A. And when you take the union, you always get the bigger one, which is the universal set. That is what we have here. And then, what about the intersection of A and the empty set? Please note also, I have noted this somewhere, that the empty set is always a subset of every set. It is always contained in every set. And so if you take the intersection, since it's contained in A, it will give you the empty set. And when you take the union, you get the bigger set, which is A. So we call those the identity properties. Okay, and then we have the complement properties. Okay, so the empty set, if you take the complement, you get the universal set. If you take the complement of the universal set, you get the empty set. If you take the intersection of a set and its complement, because they don't have anything in common, you always get the empty set. No element will be there. And if you take the union of a set and its complement, you get the universal set. Just as we saw also under the number system, that if you take the union of Q, which is a set of rational numbers, with the Q complement, the set of irrational numbers, you will get the universal set, which is what? The R. Okay, so that's what we have here. And then the complement of a set will always give you the set itself. Okay, so these properties are very basic and important. Now, the last one, which not the last anywhere, we have here is the De Morgan's rule, or the De Morgan's law, what we can also call the De Morgan's properties. It says that if I have the union of two sets, and then I want to take the complement, that is just the same thing as taking the complement of the two sets individually, and then I will now take the intersection. And the same thing is applicable if I have the intersection of two sets and I'm taking the complement. That is just the same thing as taking the complement of the two of them and then taking their union. So the complement will turn union to what? Intersection, and it will turn intersection to what? Union. And we call this the De Morgan's property. And then the last one we are going to look at here is what we call the inclusion and exclusion property. the inclusion and exclusion property. Very important property that we are going to talk about here. And what is this saying? It's talking about the cardinality of the union of two sets. If I have the A and B taking their union, so how do I get their intersection? Now, we are saying here that it is possible to get the intersection of A and B, the cardinality of A and the cardinality of B minus the cardinality of A intersection B. So this is called the inclusion and exclusion property. And you can see that from your Venn diagram. Let's say this is my A, and I'm taking this as all of my A. And I want to shade all of my B with the slant this way. What will happen here? You will discover that, remember that A union B is the whole of this shaded portion. But you will discover that this particular intersection point was shaded 2 times. You shaded it with the slanting lines this way and the one going this way. That means for you to get the union, you are going to get all the elements, that's the cardinality of A and the cardinality of B. Then remember that the total cardinality, by the time you are taking the cardinality of A and B, you have taken the intersection 2 times. And so you are going to remove one of the intersection. And that is why we have minus the cardinality of their intersection, which is the property we call the inclusion and exclusion property. And quickly we are going to see just some examples. Call it example 1 here. N of P equal to 4 means that, okay, so look at this problem. We have that N of P is equal to 4 means this is just a definition. They're trying to tell us that when you have that cardinality of sets, that if the cardinality of P means that there are 4 elements in that set P, that means the cardinality of X union Y is 50, cardinality of X is 20, and the cardinality of Y is 40, that we should find the cardinality of N intersection Y. So you discover that you can actually handle this problem using this exclusion and inclusion property. And so what should I do? So I should note that, recall that the cardinality of X union Y is equal to cardinality of X plus the cardinality of Y minus the cardinality of X intersection Y. And that's going to give me 20 plus 40 minus, this one is 50. And so we are now looking for this cardinality of X intersection Y. So quickly make this the subject by bringing it here. So you are going to have that the cardinality of X intersection Y is simply going to be the sum of this, which is 60 minus 50. And that is equal to what? 10. So that particular property makes the solution of this very simple. So we look at the second problem. The problem says that if Mx is defined as a set of the multiples of X, and Fx is defined as a set of the factors of X, that we should find M3 intersection F12. That means we should find what is M3 then. If Mx means multiples of X, that means M3 will mean multiples of 3. And remember, multiples of 3 can be positive and negative. And of course, they will always start with 0. 0 is a multiple of 3 because 3 times 0 will give you what? 0. And then to the right, you have 3, you have 6, and so on. To the left, you have minus 3, you have minus 6, and so on also. So this one is an infinite set. However, what about our F12, the factors of 12? Remember also, the factors of 12 are also going to include both positive and negative, because of course, 1 can divide 12, and minus 1 can also divide 12. And so that means the factors of 12 are going to include the negative values, which are minus 12, we'll have minus 6, we'll have minus 4, minus 3, minus 2 will be there, minus 1 will be there. Of course, there won't be 0 because 0 cannot divide a number. And then we'll have 1, we'll have 2, 3. So we have all of these as the factors of what? Of 12. Okay, so that is to say then that the question they're asking us to find, which is M3 intersection F12 is simply going to give us all the values that we have here. Of course, we see that 12 will also be a multiple of 3. That means minus 12 will be there. We'll have minus 6 will be there. We'll have minus 3. What again? 0 is not there. And then the positives. That means 3, 6, and 12 also. So this is going to be the intersection that we are going to be looking for. All right. Okay, so that is all that we are going to see in this video. Please do well to click the thumbs up, that's the like button, and also do well to subscribe to our YouTube channel for more interesting content, as they share also to your friends that are also learning topics like this. And see you in the next video. Thank you.